Hello, my name is Andy Higginbotham and I'm the Senior Admissions Tutor for Physics at the University of York. We're really excited that you're considering joining us for one of our degree programmes. In this video, I'll give you a brief introduction to our programmes, what we teach, how we teach it, and just as importantly, how we support you through your degree and beyond into postgraduate study or employment. If you're watching this, you've probably already decided that studying physics is a worthwhile pursuit. For some of you, it might be a desire to understand the fundamental nature of the universe and to advance the very frontiers of human knowledge. Perhaps you want to delve into the mysteries of dark matter or to study the building blocks of the universe. For others, physics is also about the societally useful skills and knowledge it encompasses. Physics has always sat at the very heart of technological advancement. Thermodynamics drove progress in the Industrial Revolution. Quantum mechanics and solid-state physics have given us the semiconductor age. As I'll show you later in this video, physics continues to play a role in tackling some of society's greatest challenges. Whether you plan to push the boundaries of knowledge or want a degree which will prepare you for a more applied career, Physics at York has the modules, facilities and support to help you reach your goals. York is a member of the Russell Group of universities, meaning you'll be taught by expert researchers at the cutting edge of their fields. Our dedication to research-informed teaching means that this expertise will filter down into your taught modules at all levels of your degree. Our teaching is supported by a range of facilities, including our recently refurbished and upgraded teaching laboratories, our dedicated Astra campus, housing our optical, radio and solar telescopes, and for advanced labs and final year projects, access to our research laboratories. Here at York, we pride ourselves on our friendly, inclusive and supportive atmosphere. We value our undergraduate students, and during your time here, you'll be considered an important part of the department. We encourage you to interact with our academic staff and provide regular opportunities for you to become part of our physics community. But we also appreciate that important as the quality of your time here at York is, your degree is ultimately a stepping stone to something even bigger. That might be a PhD and a research career for some, and for others, perhaps a move into teaching, engineering, finance, or one of the myriad career paths open to well-trained physical scientists. We support you in this onward journey from day one with skills and employability training built into our syllabus. Now that you have an idea of what York has to offer, let me delve into a little more detail on who we are and what we do. We're a large department with around 500 undergraduate students across all years of study and around 60 members of academic staff. The majority of these staff are active researchers and teachers, but 5 are specialists in teaching and scholarship. These 5 staff are a key part of our continuing commitment to improving and modernising our teaching provision. For example, one of our teaching fellows led early trials on recording of lectures, a technology now embedded across the university, meaning that all of our lectures are audio captured, and in the case of larger lecture spaces, fully video captured. This allows you to review lectures in your own time, either to catch up on missed material, or to review content again, to cement your understanding, or as a part of your revision strategy. Innovations such as this, often led by our teaching and scholarship specialists, enhance your experience here at York, help us to ensure that you're receiving the highest quality education. Given how important research-led teaching is to the York approach, I want to start off discussing our courses by introducing you to our research topics. These might seem somewhat distant to your current studies, but as I will show you, our programmes are designed to build on your current knowledge and skills so that you can engage with research-level project work in the final year of your degree. Our research is split into a number of areas. Condensed matter physics is the study of material in the solid and liquid phases. It might not be a topic you've had much exposure to so far in your education, but it's a crucially important part of modern physics. Encompassing materials such as semiconductors and effects like magnetism and superconductivity, it lies at the very heart of modern technological development. It's perhaps no surprise then that over 1/3 of the Nobel Prizes in physics awarded this millennium have been for discoveries in condensed matter physics. Nuclear physics is the study of the core of the atom and encompasses such fundamental topics as nuclear synthesis, the understanding of how atoms that form the world around us came to be built up in the nuclear furnaces of stars. As we will see later, it also has immense importance in industry, as the detectors pioneered in nuclear physics experiments can find commercial use in the civil nuclear industry or indeed medical applications. Plasma physics, which is one of my own areas of interest, is the study of ionized gases. Given that 99% of the observable universe is thought to be in the plasma state, the study of plasmas can give us insight into the nature and evolution of the universe. At York, we have a particular interest in nuclear fusion, utilising plasmas to harness the power of stars to create clean, safe nuclear power. We also study more down-to-earth topics, such as the use of plasmas in medical settings, for sterilisation of equipment, and even the treatment of cancers. The physics of life is an emerging area which lies on the borders of physics and biology. It's all about answering biologically motivated questions using the theories and techniques of the physicist. How do bacteria swim? This is a fluid mechanics problem. How does DNA fold and deform in the presence of other molecules? This requires complex molecular simulation. Finally, we can utilize frontier physics techniques to develop new and innovative medical technologies. Our final research area is in quantum technology. The aim here is to harness the strangeness of the quantum world, entanglement, superposition, and uncertainty to develop real consumer technologies. Here at York, our focus is on communications, and as lead partner in the EPSRC Quantum Communication Hub, we're pioneering quantum communication using entangled particles, both through the UK's dark optical fibre network and in the near future using satellite-based free space transmission. Let me give you one specific example of a recent discovery by two of our academics, Professor Dan Watts and Dr. Mikhail Bashkinov. Dan and Mikhail study hadron physics, a field concerned with the properties of matter composed of quarks. They've been instrumental in observing a new class of hadron known as the hexaquark, particle composed of 6 quarks, which looks in essence like a combination of 2 protons or neutrons. However, that apparent similarity is deceiving, as these hexaquarks act very differently to the more familiar particles which make up atomic nuclei. Most interestingly, they can form exotic states of matter known as Bose-Einstein condensates, where quantum mechanical superposition spans whole macroscopic systems, leading to truly unexpected behaviours. Dan and Mikhail have recently seen experimental evidence of a specific hexaquark known as the D-star, and most excitingly, their theoretical work suggests that Bose-Einstein condensate form is a new candidate of dark matter. If proven correct, this will be a significant step forward in our understanding of the universe. The key to observing the D-star was the development of a novel detector, and Dan and Mikhail's work on detector development is not only used for nuclear and particle physics. New detectors are critical in medical physics, where they enable new diagnostic techniques or improve existing ones. The physics of detectors is one of the topics explored in our new medical physics module, led by Mikhail and available to our third-year undergraduates. Developing new improved medical diagnostics, or making current ones at a lower cost, is just one area in which our researchers are aiming to address major societal challenges. Our academics are advancing our understanding in some of the most important and impactful areas of modern life. For example, investigating energy-efficient materials to reduce the pace of climate change, creating new approaches to ensure nuclear security at our borders, and investigating the molecular mechanisms leading to the onset of Alzheimer's disease. So, how do we take you on your journey from your current studies to being able to explore these exciting areas of science? We offer a number of programs, each designed to help you engage with physics in a way which matches your interests and goals. Our straight physics degree covers the broadest range of physics with a wide range of optionality and laboratory-based training which encompasses all of the major areas of physics. If you want to keep your options wide open or to experience the whole gamut of physics, this might be the course for you. Our physics with astrophysics degrees cater to those who want to gain the same core knowledge and skills as any physicist, but want a firm grounding in the theory and experimental techniques of the astrophysicist. You'll have access to our telescopes at the Astro Campus as part of our astrophysics laboratory course and take specific modules aimed to build your knowledge of the cosmos. For those who prefer to engage with theory rather than hands-on experiment, we offer theoretical physics degrees. Specialist computational labs and mathematical modelling modules will teach you to undertake complex scientific investigations by writing advanced parallel computer programs capable of utilising state-of-the-art supercomputers. This highly employable skill will allow you to investigate some of nature's most challenging phenomena. We also offer joint courses with maths and philosophy, both of which allow you to forego the more practical elements of the course to spend time with our colleagues in other departments, developing additional knowledge in foundational mathematics or the wider theory of human thought and knowledge. For those of you who might not have had the chance to study maths and/or physics at the required level, we have a specialist foundation year option to bring you up to speed before you transfer to another of our courses. All of our courses are available as a 3-year BSc or 4 years master's option and are accredited by the Institute of Physics. Most of our degrees offer an option of an additional year, either studying abroad or working in industry. These additional years allow you to build confidence in a new environment, gain valuable skills and experience, and show future employers that you can thrive outside of the usual academic environment. Check out our web pages for more information on these options. Our recently redesigned degree is structured to build up your foundational knowledge in years 1 and 2 via our core modules, before introducing you to increasingly research-aligned topics via our optional modules in years 3 and 4. All of this builds towards a final year project embedded within one of our leading research groups. A few examples of the modules you will study are shown here. Core Stage 1 and 2 modules cover the topics any physicist would expect to master: mechanics, optics, quantum mechanics, relativity, mathematics, and more. In later stages, you start to see a shift to more advanced topics, such as cosmology, particle physics, and spintronics. The full range of modules for each course is listed on our website. We teach our courses through a combination of lectures, smaller group teaching, and laboratory elements. You can see a sample week from a first-year timetable here. Lectures, shown in dark blue, will often be your first chance to engage with new material, making notes, asking questions, and defining the scope of the course. This learning is supported by smaller, more targeted sessions, such as problem classes, where groups of around 30 students will solve problems under the supervision and guidance of the course lecturer, building up competence in applying their knowledge. To really tackle the trickiest conceptual elements of the course, we offer tutorials, small group classes of 4 to 5 students who can ask their tutor for help on any issues they're facing on the course. These valuable student-led sessions should really allow you to get to grips with even the most complex of ideas. All of this builds to a final year project, where you'll work in a group or individually to tackle a research question with one of our academics. A few examples of past projects are shown here. As you can see, they align with our key research interests, completing your journey from college-level study to the frontiers of human knowledge and understanding. For your time here at York, we want you to be part of our physics community. To support you in that aim, we have an open-door policy for meeting our academics. You can talk to any of us at any time about our courses, our research, or any other topic of interest. You'll also have a dedicated personal supervisor who will guide you through your degree, assisting with any academic, pastoral, or employment-related queries or concerns. We have 2 recently refurbished study spaces dedicated to undergraduate use in the department, as well as a series of more informal breakout spaces within our buildings, which you're welcome to use. Finally, I want to talk about careers and employability. Around 40% of our graduates go on to further study, with the other 60% entering into the workforce. Regardless of your intended path, we work hard to support you in gaining the skills you will need to thrive once you move beyond undergraduate life. We provide professional skills training throughout your programme, training you in CV writing, time management, presentation skills, and report writing, to name just a few areas. We also offer opportunities to engage with future employers via the White Rose Industrial Physics Academy, a team based at York dedicated to linking you with potential employers. This includes assisting you in finding summer internships, organising our year in industry programmes, and arranging visits and talks from leading graduate employers. They even organise the UK's largest physics-specific careers fair, ensuring that you can meet the contacts you need to successfully make your next steps. All applications to our courses are via UCAS, and you can see our standard entry requirements for the most common qualifications here. We also offer scholarships and guaranteed summer placements known as masterclasses to high-achieving applicants. If you are on course for an A-star at A-level in physics or maths, or an equivalent grade in your qualification, you will be eligible. More information on the scheme is on our website. I hope this video has given you a flavour of what physics at York might be like, and how it can help you reach your goals. If you have any more questions, please check out our website at york.ac.uk/physics, email us on physics-admissions@york.ac.uk, or join us in a chat room at one of our virtual open days. We'll always be happy to answer any queries you have.